Hello everyone. Today we will learn about pulse width modulation and demodulation practical. And this is the pulse width modulation and demodulation kit. So here we are given modulating signal, and here pulse trend, which is carrier signal, and this is pulse width modulator, and this is pulse width demodulator. So first of all, we want to see the modulating signal, which is the type of sine wave. So for this, we have to connect this TP2, that is the output of modulating signal, and ground to the CRO. So now I connect CRO. Okay, this is noise signal, and now I connect output, and this is ground. Okay, so you can see nothing here because the level of modulating signal is at 0. So as I increase the level here, you can see the signal will be modified. And first of all, we have to switch on. Okay, so now you can see this switch is already on, and modulating signal level is at 0. So we get nothing in CRO. Now I adjust the level, so you can see the sine wave. Okay, so this is our modulating signal, and we have to take the photo of this image via pen drive using this switch. So this is one aspect of this practical. Now what we have to do, we want to see the pulse trend carrier wave, and for this we will connect this output pin to TP1, that is the output of carrier, and this ground pin to the ground. So now you can see this is our carrier. So to see to see this picture clearly, we press auto set key. So now we are able to see the carrier wave. So here we we can see the length of pulse trend, that is, this is positive and negative, all are equal. This width, this width, this width, this width, and also lower side, this width, this width, this width, all are equal. So this is our carrier wave, and this wave we have to collect in our pen drive using this pin, and switching this key or press this key. So this is another aspect of this practical. Now we want to see the modulated view, and for this, what we have to do, we will connect the carrier wave into input. So this is our TP1 carrier wave input, and we will connect it into input. And now modulating wave, we will connect output of modulating wave into input. Okay, and this is the output of modulated wave. So connect the CRO pin to output of modulated wave, and ground to ground. So you can see this is the modulated wave. Now how we can say that this is modulated wave, because the waveform of modulated wave and carrier wave both are equal, but you can see in modulated wave the width of this pulse trend is different. So okay, so now you can see the width from this to this line, the width of our pulse trend is increasing, and then after it will decrease. So we can say that this is our modulated wave. Okay, and again you have to take photo. Now we want to see the waveform of demodulated wave. So for this, what we do, we connect output of modulated wave into input of demodulator circuit. So this is our output of modulated wave, and we will connect it to the input of demodulated. Now the demodulated output will collect using oscilloscope. So this is our this is our demodulated wave. Okay, this is our demodulated wave. Now again we will insert our pen drive and press this switch. We can take photo of our demodulated wave. So this is all about pulse width modulation and demodulation. And at last we have to calculate the modulation index. And for this we will use the formula of modulation index is equals to magnitude of amplitude modulated wave and amplitude of carrier wave. Okay, and this you can see this is our modulated wave, and the amplitude of modulated wave you can see peak to peak voltage 7.6.72 volt. This is our em, and this is our carrier wave, and amplitude of carrier wave is 6.24. Using these two values we can calculate modulation index. Okay, thank you.